morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today we are going to learn empirical rule. So, first we will see the which topics we will cover in our class. First, what is empirical rule? Then 3 sigma, normal distributions, properties of normal distributions. What is outlier? How is the empirical rule used and benefits of the empirical rule? These things we will see in our class. First, what is the empirical rule? Actually, empirical rule is referred to as 3 sigma rule, or we can say 68, 95, 99.7. That means in previous class, we have seen that some measures of statistics where we have seen some coefficient variation, and these values are related to that coefficient of variables, and this empirical rule is related to our statistics, and in the empirical rule it's containing the 3 sigma, and these 3 sigma are 68, 95 and 99.7. And this is the actually statistical rule where every normal distributions are very important, and that normal distribution will contain some observed data, and all these observed data will fall within the 3 standard deviation, and these standard deviation mostly denoted by the sigma, then mean and average denoted by mu. And in the statistic, actually empirical rule states that 99.7 of the data occurs within the 3 standard deviation of the mean and within a normal distribution. Now, that means whatever you have a data, that data is accurate, 99.7% that data is accurate. Then at the end, 68% of the data is observed within the first standard deviation. That means these are our sigma, that 3 sigma are 68, 95 and 99.7, and this 68 representing that your first standard deviation. Your data is your data is available within the first standard deviation. Then 95% will take place in the second deviation, and the 99.7 within the third standard deviation. So I already told that the standard deviation is totally related to empirical rule. It's totally related to statistics, and these things are very important. That means when you are observing that these 3 sigmas, and these 3 sigmas are containing your deviations. 68 will contain standard deviation, 95 second deviation, and the 99.5 is your third deviation. And that means the empirical rule is used to predict the probability distribution for set of outcomes. In probability module, we have seen that how to find out the outcomes and how to find out the probability distribution. So by using this empirical rule, we can predict our probability distributions. So for example, we will take the example of the exam score. Let's say we are measuring the score of the exam, and the score generally, and these things we will draw in the form of the bell shape, and this score we will show in the bell shape normal distribution, and the average of the exam is 84%, and that means standard deviation was 6%. We have considered the 84% is your average of the exam, and the 6% is your standard deviation. Now, about the 68%, the class record between 78%, class record is 78% and the 90%. Because 78 is 6 unit below 84 and 90 is a 6 unit above 84. So this is your class deviation. What I said that 84 is your average of the exam. to find out about 68%. So when you will find out, you will observe 78% and 90%. Here also you can see 6% difference. Here you see 6% difference. So these things are talking about our 68% standard deviation. If we had asked what percent of the class scored between 72 and 96%, we notice that 72 is a 2 standard deviation. Our 72 is your second standard deviation. That means it is the below the mean. And the 96 is 2 standard deviation, which is above the mean. So the empirical tools tells that about the 95% of the class scored in the range. Now let's assume the population of animals in zoo to known as a normally distributed. So each animal generally will live 13.1 years old and average, that is our mean, and the standard deviation of this lifespan is a 1.5%. So we have to consider that here each animal lives near about 13.1 years and it's a standard deviation, that means lifespan is 1.5 years. So if someone wants to know the probability of that animal will live longer than 14.6 years, they could use the empirical rule. That means when we will use the empirical rule, if we want to find out the probability of that animal wants to, how much time that animal will live. So at that time we can use the probability, at that time we can use the empirical rule. So knowing the distribution mean 13.1 years old, the following age ranges occur each standard deviation. So definitely we will get the some ranges. So first is standard deviation. This is our formula standard deviation, mu plus minus sigma. So your average mean, that is mean is a 13.1 and your standard deviation is 1.5. So we can get the range 11.6 to 14.6 years. Then when you have to find out in the second standard deviation, 2 standard deviation, then again your formula is changing. Now your formula is mu plus minus 2 sigma. So again you have to find out the range, and now you got the range 10.1 to 16.1. Then you have to find out the 3 standard deviation. Again your formula is changing. Now mu plus minus 3 sigma. So here you are getting the range 8.6 to 17.6. That means your range is changing according to the standard deviation. If it's a 1 standard deviation, 2 standard deviation, 3 standard deviation, then you are getting different ranges. So the problem solving this we need to calculate the total probability the animal living 14.6 years or longer. And the empirical rule shows that 68% of the distribution lies within 1 standard deviation. And in this case, from 11.6 to 14.6 years. These are 68%. And the remaining 32% of the distribution lies outside the range. So, this one half lies above 14.6 and other below 11.6. So, probability of the animal living for more than 14.6 is near about the 16%, and how we will calculated as the 32% divided by 2. And another example again we can consider, instead of that animal, we can consider instead that animal in the zoo lives to average 10 years of age with the standard deviation 1.4 years. Now again our range will be changed. Continuously our range will be changed. Now zookeeper attempts to figure out probability of animal living for more than 7.2 years. Now our problem is continuously changed. So when we will find out the one standard deviation, we will get the range 8.6 to 11.4. So our mu is 7.2. More than 7.2 years. So we have to find out now range. So our first range got 8.6 to 11.4. So here you have to keep these values. Take average 10 years of age and 1.4 years. So when you will keep these values, you can find out these ranges. Then 2 standard deviation, you will get the 7.2 to 12.8. Then 3 standard deviation, 5.8 to 14.2. These ranges we are getting. And empirical rule states that the 95% of the distribution lies within the 2 standard deviation. And the 5% lies outside 2 standard deviation. That means half about 12.8 years and half below 7.2 years. So the probability of living more than 7.2 years, we can find out 95% plus minus 5% divided by 2 is equal to 97.5. This is our probability. So first, now we will understand what is the empirical rule. Actually, empirical rule is often in statistics for forecasting final outcomes. And actually, when you have to calculate, after calculating the standard deviation and before collecting the exact data, this rule can be used as a rough estimate of the outcome for impending your data to be collected and analyzed. And the empirical rule is generally used in the statistics for the forecasting final outcomes. And these outcomes are very important for collecting the analyzing your data. And the empirical rule is generally used rough way, that means for testing the distributions, and that is your normality. And if too many data points fall outside the standard deviation boundaries, that means it is showing that your distribution is not a normal. Your distribution is not normal. That means it may be skewed data. It may be follow some other distribution. And the empirical rule, generally known as the 3 sigma rule. It is the 3 sigma rule, and these 3 sigma rule represent some statistical distribution of the data within the standard deviation from mean on a normal distribution, where we can use the bell curve. So see, this is the your normal distribution. This normal distribution we have shown, this is your bell curve, bell shape. This is your standard deviation from the mean. This row is showing standard deviation from mean. Then this is your z-score and t-score. And here you can find out the probability of cases in the portion of the curve. X bar is showing your mean. Now what is 3 sigma? Till now we have used the 3 sigma, and we are saying that the empirical rule is about the all 3 sigma. So what is meant by 3 sigma? And this 3 sigma is generally statistical calculation, where we are finding out where data are within the 3 standard deviation. Standard deviation from the mean. And in generally in business application, 3 sigma is used to process that operate efficiently and produce items of the highest quality. And these 3 sigma limits are used, set the upper and lower control limits in your statistical quality control chart. Whenever you have to draw the quality control chart, so at that time your 3 sigma limit will be more useful. And these control charts are used for establishing the limits for manufacturing, or we can say that business process that is in the state of the statistical control. Now these control charts are generally known as, we can Shewhart charts, named after Walter A. Shewhart, who was an American physicist, engineer and statistician. And these control charts mainly based on the theory in perfectly designed process and certain amount of variability in output measurement of inherent. And these control charts determine if there is a controlled or uncontrolled variation in the process. And these variations in the process quality due to random causes are said to be in control. Out of the control process include both random and special causes of variation. So we can know, we can get here, there are two types of the variation. One is the random variation and another one is the special variation. And these both variations are important. These both, with the help of these variation, we can find out the quality in the control and out of the control process. And control charts are intended to determine the presence of the special causes. Which special causes we have to find out. All these things are explaining in the 3 sigma limits. And to measure the variation, like statistician and analyst use a metric known as the standard deviation, that is called your sigma. And this sigma is a statistical measurement of the variability where it is showing that how much variation exists from the statistical average. That means whenever we have to find out the empirical rule, we have some average and on that basis we are getting the standard deviation. We are getting this mean. So we can find out the statistical measurement of the variable and we can find out the how much variation it is showing as compared to average. And to understand this measurement curve, you have to consider the normal bell curve, which is a normal distribution. And the farther to right or left data point is recorded on the bell curve and higher or lower respectively, generally the data is than the mean. And from another point of view, if we see the another point of view, low values indicate the data point fall close to the mean. Low value are related to the, are very close to the mean, and high values indicate that widespread and not close to the average also. Now we will see the normal distribution. What is meant by normal distribution? Normal distribution is known as Gaussian distribution. And this is probability distribution that is symmetric about the mean. Actually, it is showing that data near the mean are more frequent in occurrence than the data from the mean. And see, normal distribution is showing that the data near the mean more frequent as compared to data far from the mean. In graphical form, normal distribution appears in the bell curve. Generally, normal distribution is a common type of the distribution which is assumed technical stock market analysis in other types of the statistical analysis. And standard normal distribution it will use generally two parameters. These are first mean and another one is the standard deviation. Normal distribution model is very important in the statistics and it is a key to central limit theorem. And these things state that average is calculated from independent, identically distributed random variable have approximately normal distributions regardless of the type of distribution from which the variables are sampled. So this theory, actually central limit theorem, is saying that your average you can calculate from the independent, then identically you can distribute random variables also on the basis of normal distribution. And the normal distribution generally is one type of the symmetrical distribution. And this symmetrical distribution occur when you will divide the line produced two mirror images. That means when you will produce the two mirror images, at that time your distribution is the symmetrical distribution. Otherwise it will show the asymmetrical distribution. And not all the symmetrical distribution are normal. Because Some data could appear as a two humps or series of the hills in the addition to the bell curve that indicates the normal distribution. And this normal distribution, or we can say it's a Gaussian distribution, it's totally symmetrical bell-shaped curve. And the peak of the curve denotes the average data point. Peak of the curve, it's denote the average data point. And when you will compile or you will graph that data, it may many continuous large data set in nature exhibit the bell-shaped curve. But let's see that common example, normal distribution, and we have to find out the height of the person. Now, population's height is an example of the normal distribution. Majority of person in given population are the average height. The number of person who are taller and shorter than the average height is almost equal. And only few people are either extraordinary tall or extremely short. So, what we are doing, we are finding out the normal distribution of the height of the person. So, here, as a result, when we will check the height of the person, so we can plot the height of the all people in the world, and the graph will follow the bell shape, the normal distribution. So, now we will see another example of the rolling dice. A fair dice roll also create bell-shaped curve, which is denoting your normal distribution, and this normal distribution graph is becoming increasingly sophisticated as the number of dice increases. See, when you are rolling a one die, so at that time you can get only 6 possibilities. You can get only 6 possibilities, and every time you will get the 1 by 6 probability. Then again, when you are rolling 2 dice, your possibilities are changing. Your possibilities are changing. When you are rolling again 3 dice, your possibilities, your outcomes are changing, and when you are again rolling a 4 dice, your possibilities are changing. So every time we can find out our normal distribution. We can find out our normal distribution according to our outcomes. So similarly, there are many more things in the world that you can follow the distribution. IQ of the population sample. On the basis of IQ of population, you can find, you can draw the normal distribution, income distribution in the economy, performance of the employees in the company, shoe size of the person, birth rate of the population, and many more. So, on this basis, by using these formulas, you can find out, you can draw the normal distribution. And this normal distribution you have to show in the form of only bell-shaped curve. Now, what are the probabilities of normal distribution? Actually, normal distribution has several key features and the properties. First, it's a mean. That means we can say it's average. Median. It's explaining about the midpoint. Then mode. That means most frequent observation are all equal to one another. So these values all represent the peak and highest point of the distribution. And the distribution then falls symmetrically around the mean and width, which is defined by the standard deviation. So your distribution is false according to the symmetrically. And these things we will explain, you will define by the standard deviation. Now, what is your 68, 95, 99.7 rule? Actually, after every observation of the multiple normal distribution curve, statistic found a common pattern in the data. And that common pattern is that 68%, 95% and 99.5%. So, this pattern is observing. This pattern we are observing in the data. This was a common observation in all normal distribution graphs. And it became a rule, we call it the empirical rule of normal distribution. That is 68, 95, 99 rule. In other words, we can say that empirical rule is based on your experience and the observation. Empirical rule, totally based on what you have experienced and what you have observed. On that basis, you can find out your empirical rule. And it gives the how much of the data lies within the 1, 2 or 3 standard deviation. It is telling that how much data is lying within 1 deviation, 2 standard deviation or 3 standard deviation. And 68, 95 and 99.7 was discovered by the name of Abraham de Moivre during his experimentation of flipping 100 fair coins. And this term was coined 75 years before normal distribution model even was introduced. Let's understand this 68, 95, 99.7 rule more clearly. As per the empirical rule, 68% observed data within 1 standard deviation, 99% data 2 standard deviation, and the 99.7 within 3 standard deviation. And empirical rule is also known as the 3 sigma because of only these 3 standard deviation. Because practically every time all data will fall within the 3 standard deviation. Without 3 standard deviation, you can't say the empirical rule. Actually, your empirical rule is containing 3 sigma, and that 3 sigmas are your 68%, 95% and 99.7%. So, your empirical rule is fall within the 3 standard deviation. And these rules establishes both upper and lower bounds of the statistical chart. That means plus minus 3 standard deviation. Now, since 99.7% all fall inside it, and this limit is also used for identifying the outliers, and all the data point which lie beyond the plus minus 3 standard deviation is considered as an outlier. Now, what is meant by outlier? Let's consider average weight of the first 4 kid. Average weight. First kid has weight 30 kg. Then 35 kg, 40 kg and 50 kg. Now, we have find out the average weight of these 4 kg. And we got the average weight 38.75 kg. But now what happened? Another kid weight we have added. So now our average weight, see, 30 plus 35, 40, 50, 300. We have added and divided by 5. So our average weight is a 91 kg. So now what is happening here? This number is totally near about these values. But if you observe that 91, you can find out these things are not, this value is not related, not close to 30, 35, 40, 50 or 300 also. So that means this is your outlier. These things is your outlier. So totally it's a different thing. And the average weight of the first kid, we have observed that it is a 38.75 and the average weight of the all kid, it's a 91 kg. But adding weight, how it's a changing? Only because of when you have added 300s with that 4 kids weight. So your average weight is totally changing and it is showing from 38.75 to 91 kg. That means it's changing from 38.75 to 91 kg, and in statistics that is called the outlier. That is called outlier, and in outlier, the outlier is a value in the data set that is extremely distinct from most of the other values. Again, let's understand the outlier by the example of the cricket. Highest batting average of the player in the test cricket is C. Highest batting average. So when you will observe this table, every value is near about. Every value are close to each other. But when you will see that 99.94 average, so it is totally different. This value is not close to this value. So that value is an outlier. Our This is your outlier. When you will observe these values, average values, every value is close to each other. But this value is not close to each other. This value is totally different. That's why it's a outlier. And this, in the above table, batting average of DG Bradman is a 99.64, and while batting averages all remaining is between 54 to 62, and you have already seen that in this table. And so the batting average of DG Bradman is an outlier in the above list, and the outlier in the above data is due to variability in the data, experimental error, heavy skewness in the data, or missing values. These are the causes of happening the outliers in your data. Now, how is the empirical rule is used? Actually, empirical rule is used to apply to anticipate the probable outcomes in the normal distribution. But statistician would use these two to estimate the percentage of the cases that fall in each standard deviation. So consider the standard deviation is a 3.1 and mean equal to 10. Now you have to consider the standard deviation 3.1 and mean 10. So on this basis, we will find out again the empirical rule. We will find out the range. Now, first standard deviation would range between the 6.8 to 13.2. Then standard deviation, again your range is like 3.6 to 16.4. 6.8 to 13.2. One standard deviation. Then 3.6 to 16.4. This is two standard deviation. Then this is like this, we can use our empirical rule. Now we will see the benefits of the empirical rule. If you will use the empirical rule, it serve as a mean of the forecasting data. Then this is especially true when it comes to large data set and those where variables are unknown. You know, these data generally we are using in the probability form. We have to find out the probability, possibility. So at that time, we can use this empirical rule, and this is very useful in the statistic. And when you will use the large data set, and that variable also should be unknown. And in finance specifically, empirical rule is germane to stock prices, for prices index, log values of forex rates, which all tend to fall across a bell curve or the normal distribution. This is your graphical explanation. Standard normal distribution. This is a 68%, one standard deviation, two standard deviation, and three standard deviation. And this empirical rule is followed between these three standard deviation, which we called as 3 sigma. Now normal distribution is associated with 68, 95 and 99.7 rule, which is known as the 3 sigma, 68% one standard deviation of the mean, 95% two standard deviation of the mean, and the 99.7 is the 3 standard deviation of the mean. This is your empirical rule formula. Mu plus minus m sigma. Mu is your mean. Sigma is your standard deviation and m is your multiplier. Now we will take one example. Suppose the pulse rate of 100 students are bell-shaped with the mean of 75 and the standard deviation 4. Now what? First we will find out one standard deviation, that is cover 68%. So 75 plus minus 1 into 4, we got the 71 and 79. So our range is 71 to 79 in one standard deviation. Then 95% of the student have the pulse rate in interval 75 plus minus 2 into 4. Now again our range is changing, that is the 67 to 83. This is your 2 standard deviation. Then again 99.7% student have pulse rate interval 75 plus minus 3 into 4. So you are getting the range 63 to 87%. That means 3 standard deviation. Now for data with a roughly bell-shaped distribution, 68% within 1 standard deviation, 2 standard deviation and 3 standard deviation. 1 standard deviation, this is your 68%. Minus 1 and minus 2. This area is showing 68%. Then minus 2 standard deviation and plus 2 standard deviation. Within 2 standard deviation, you can see that your bell shape is like that. This is showing the 2 standard deviation 95%. And the third one, within 3 standard deviation, you can see your shape is showing 99.7% within the 3 standard deviation. Now just we have implemented this thing using 68, 95, 99.7%. When you will import this thing, just we have to take the mean equal to 0 and standard deviation is equal to 1. And on that basis, we have to find out the all values. Now, 1 standard deviation, 2 standard deviation and 3 standard deviation. And now we have to bring the 1 standard deviation, 2 standard deviation and 3 standard deviation. When you have to find out, when you will execute these things, you will get the 1 standard deviation like 0.68 with 2 standard deviation 0.95 and 3 standard deviation 0.99.7. So definitely on this basis you can get this value and you can check, you can implement your 68, 99, 95 and 99.7 rule. This is all about the empirical rule. In today's session, we have seen so many things. What is empirical rule? After that, we have seen how we have to solve this empirical rule problem. What is the 3 sigma limits? These things we have learned. Then normal distribution. Then again, we have seen the normal distribution, how to calculate, how to draw the normal distribution by using the rolling dice. Then properties of the normal distribution. Again, we have seen this 68, 95 and 99.7 rule. Then in empirical rule, how we have to find out the outlier, how we have to recognize the outlier. These things we have found out. Then how we have to use the empirical rule. All these things we have checked, we have seen in the today's session. So these are your references. You can refer these things. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.